everybody. Welcome to Statistics and Theory. In this presentation, I'm going to demonstrate how to do a structural equation modeling analysis using Amos. The data set that I'm going to use consists of a few constructs, and I'm going to investigate how these constructs affect each other. The first construct, as you see here in this SPSS file, is motivation, and it includes 3 items, and these are the items on the right hand side. In addition, I've got 3 stress items which basically measure the amount of stress in students. And finally, I have positivity items, which are also 3, and they measure the amount of positivity as self-appraised by students. Now I want to figure out how these 3 constructs would affect the construct of language ability, which is measured by 5 indicators. One of them is the grammar score of students, the other one is vocabulary, then comprehension score, and then situational writing, task fulfillment, and situational writing, the language ability of test takers. So let's see how we can demonstrate the relationship between these 4 constructs. The model that I want to arrive at is this model, which I've already created, but I will show you how to do this. As you see, positivity, stress, and motivation are those 3 constructs that have an impact on language. Now, before doing the analysis in Amos, I should say that I highly recommend that you watch 2 other videos that I have created about confirmatory factor analysis, because a predecessor to structural equation modeling is confirmatory factor analysis, and that will help you to validate each of these smaller models inside your structural equation modeling analysis. So I'm not going to go through the validation, the psychometric validation of these 4 models, because they have already been explained. But as the first step in structural equation modeling analysis, I would highly recommend that you do look into the fit of each of these single models per se. So you need to generate 4 separate models, one for positivity, one for stress, and then one for motivation, and then one for language, and then look into the fit of those 4 models before you put everything into this structural equation model. So I hope that you will watch those videos. I will leave the links in the comments section under this video. Now let's go through Amos. Amos has a look like this. It's quite user-friendly. So the first thing that we want to do is to create the motivation constructs, as you see, these 3. So in order to do this, we need to associate the SPSS file that you see with Amos. So we have to open it through in Amos. You can do it either through File, or you can do it from this button, that's Select Data Files. I'm going to click on this, and I'm going to click File Name. So I will go to Desktop. That's where I am saving my data set. This data set is called sample data. I'm going to click and open, and I've got it. As you see, the data set is pretty large. It consists of 1,896 students' performance on those 4 skills that I mentioned before. Then I'm going to click OK to open the data set. There we are. Now, from this menu, which lists the variables, I can look at the list of the variables. There we are. Let me drag it from the side so all the variables will be visible. So it's exactly the same list which I showed you in the SPSS file. Now I need to move these to a model that I am going to generate. So first click on Draw Latent Variable and draw a circle like this. And then, since we have got 3 variables here, 1, 2, 3 for the first construct, I'm going to click 3 times. Each time you click, one indicator appears, 1, 2, 3. And then I'm going to rotate this using this Rotate the Indicator button in this way, because this would look better this way. Okay, so that's our first construct. Then we can go through the same process for the third and fourth and for the second, third, and fourth constructs. But what I would like to do, instead of doing all that, because that's going to take quite more time, what I would like to do is to click on this button, which selects all objects, and it turns blue. Whenever the objects turn blue in Amos, you actually have selected all of them. So you can now move, for example, you can move this around this way. So everything, including the indicators and the latent variables, will be moved around easily. Now what I would like to do is to duplicate this, so I won't have to keep designing it again and again for other constructs. So I'm going to click duplicate object and draw this, just drag it down and drag it down once more to draw the third construct. In order to draw the last construct, which is the language construct, as you see here, I can do the same thing, but I'm going to move it to the other side so that I can easily see the effect and draw the effect of these variables visually from the latent trait to from the latent variable to the latent variable of language. Now so far it's fine. What I would like to do is to unselect everything so the color changes, and next I would like to rotate this further to the left hand side, so that's this represents language. Since we've got 5 variables indicating language or measuring language, what I would like to do at this point is to add 2 more indicators to this factor. So I'm going back to draw a latent variable again, and this time around I just click twice, once 1 and 2, so the 2 variables will be generated. Next I'm going to unclick this. I'd like to now click preserve symmetries and click trucks. This is a very helpful combination. When you click preserve symmetries and the truck, you can move the entire construct and its indicators around like this. And you can do this for the rest of the constructs as well. Now at this point, what I would like to do is to draw arrows from the first construct to language. Actually, I'm going to name them right after this, and the second one and the third one as well. I'm going to name the first construct by double clicking on the oval shape or the circle and name the variable as, let's call it motivation, to let's call this stress, 3, I can call it positivity, and this one you can call this language. The names are arbitrary and depends on your model, the theoretical model that you want to investigate. Now I'm going to close this. Next is we need to move these items to the indicators or the boxes here. So we can move this one at a time, but as you will see, the labels will also move to the indicators, but that's fine, we can take care of that later. 2 and motivation 3. Now if you do the same process for the rest, you'll get a kind of messy model in which the labels are sticking out of the indicators. So you can right click a couple of times on the indicator and just remove variable label. That's it. So the only thing which is left is now the variable name. Next is you can go you don't have to close this, click on the second indicator and remove the second variable label as well, and do the same thing for the third one. So now our motivation has been created. You can do the same thing for stress and positivity. So I'm going to close this, and before naming the rest of the indicators, I would like to show you how to name these little circles, which, as I have explained in another videos, actually 2 videos on confirmatory factor analysis, they're called errors of measurement. So click on plugins, name unobserved variables, and every unobserved variable will be automatically named. So far, what we have defined is three exogenous variables, which are pretty much like independent variables, which have an influence on an endogenous variable, which is language here. Endogenous is similar to dependent variables because it receives some impact from external variables like motivation and stress and positivity in this analysis. Since language is an endogenous variable, it needs to have an error of measurement connected to it. That error of measurement is called disturbance. I'm going to add that error of measurement here manually, so I'm going to click this, add a unique variable on the existing variable. So here I just click and I create this. In order to name this disturbance, or they call it, it also goes by uniqueness, I can click on plugins, I can name unobserved, click name unobserved variable, and there we go. Or you could do it manually. I suggest that you just use this option. Really, that's much easier. It will save a lot of time. Now we also need to move these variables to each of these sections. I've already done that, so let's just save some time, and let me just click on my model 1. So if I don't save this, I will actually lose everything I've done, which is fine because I've already gotten that. So I'm going to click no, and the model that I created before appears here. So there's every variable that you saw before in this structural equation model, and I think our analysis is now ready. We just need to go through the output and the analysis properties before running the analysis. So I'm going to click on that property button. In order to estimate this model, I would suggest that we use maximum likelihood estimation unless you're not really sure if your data is normally distributed, which in this case I assume the data is normally distributed. Since we have missing data, we need to check estimate means and intercepts. If you do not have missing data, you don't have to check this off. The other thing we should do is just to go to output, please, and check minimization history, which is by default checked already. Since I did this analysis before, I also checked standardization estimates and squared multiple correlations. In addition to that, indirect and direct total effects, because we want to measure the direct and indirect effects. Actually, we only have direct effects of stress, positivity, and motivation on language, so this is a very important option for us in this analysis. And if you're interested to look into the normality and the presence of outliers, you can check this. So that's it. Next, we can run the analysis. We're ready to run the analysis. So this is the analysis button. We can click and calculate all of the parameters. Okay, this window pops up and is asking me whether I would like to create correlations between motivation, stress, and positivity. Not at this point, because I'm going to call this model 1, and then in a second model I will correlate these three constructs, and then I will compare the fit statistics of these two models to see which one of them is better. This is basically how structural equation modeling is often done. We have a basic model like this, and then we nest the rest of the models into that by, for example, adding parameters, or by removing certain parameters, or even indicators, or latent factors like these. So let's just proceed without adding any more parameters into our analysis. Proceed with analysis. You might be prompted to save your results somewhere, so you can just save it anywhere on your computer. I've already saved that before, and this is the result of our analysis. You can toggle between standardized and unstandardized statistics. By looking at the standardized statistics, you'll see that motivation has a very low impact on language, almost nothing, and stress has a negative impact on language. And I'm not still sure if stress has the effect of stress is significant statistically or not. So I'll have to look at the output. And in the same way, positivity has more or less a similar impact of 0.17 on language. This is the beta or regression coefficient of positivity and language. Now let's look at the statistical significance of these three to figure out if the model is fine or not. So I go to estimates, and as you'll see, everything from this regression weight table, everything is statistically significant, so which is pretty good news for us. But there is no significant relationship between motivation and language. In other words, as you saw before, this connection between motivation and language doesn't have any statistical significance. So we know that motivation, as measured by those three indicators, which you saw before, doesn't have any significant impact. However, stress has a significant but negative impact on language ability, and positivity has a significant and positive impact on language ability, which is intuitively correct for us, because it would be very kind of perhaps counterintuitive if stress had a positive impact on language or language ability. Now you can scroll down to get the standardized coefficients, as you see from here. For example, for stress, you can just click on this and you can read the meaning of the standardized coefficients. For example, for the second one, this standardized coefficient means when stress goes up by 1 standard deviation, language goes up by 0.15 standard deviations. So this is basically analogous to what we call the effect size in multivariate analysis. And you can interpret the rest of them in the same way. Let's just interpret this one as well, because it was our hypothesis that positivity affects language in a positive way. So when positivity goes up by 1 standard deviation, language goes up by 0.172 standard deviations, which is pretty good. I mean, it's small, but still pretty good. So now we can move to model fit. So as you see from the fit statistics, we have a chi-squared value of 811.212, which is statistically significant. And what this indicates is that there is a statistically significant discrepancy between our model and the actual underlying structure of the data, which means that the model doesn't fit the data pretty well. And another piece of evidence for this is that this index, which is known as the normed chi-squared value, which is calculated by dividing your chi-square index by the degrees of freedom, is much larger than 3. Ideally, we would like to get something closer to 0 and definitely below 3, and this is violating that assumption. In addition, we have the CFI, comparative fit statistics, which is not too bad. I would say it's larger than 0.9, and the larger the better. And the TLI, the Tucker-Lewis index, is also, well, I'm afraid it's not very promising, because it's smaller than 0.9, but it's close to 0.9. So I would say I would probably run another analysis to figure out whether I can get a better model in terms of the chi-square values and the norm chi-square values and the other fit statistics, as you see here. Now, if you want to read more about and learn more about these statistics, I highly recommend that you take a look at our book chapter, which is published in Quantitative Data Analysis for Language Assessment, the 2nd volume, which was edited by my colleague Dr. Michelle Rackwell and myself. So if you go to this chapter under part 2, Advanced Statistical Methods, we have a chapter called Structural Equation Modeling and Language Assessment, which is co-authored by three authors, myself included, and we have provided a more detailed explanation of how this analysis is done. But for the time being, let's go back to our model and do what Amos had previously suggested, meaning to covary these three constructs. So I'm going to do that. Just really draw it manually, and that's an easy way by clicking on this correlation or the covariance button. Now that we have a correlation or covariance between all of these three constructs, we can run the analysis again. And there we are. Let's call this model 2. And we go to the output again. I would like to quickly take a look at the fit statistic. The fit has improved, but it's not that much of improvement because the norm chi-squared value is still larger than 3. However, in terms of the CFI and TLI, we have, and even IFI, we have a much better model here because they are the TLI is larger than 0.9. So that means that it meets the minimum requirements of a good and well-fitting model. The CFI is definitely acceptable as well. So if you want to do further comparisons, especially between the current model and the previous one, it's a good idea to look at their AIC and their BCC statistics. And the smaller they are, the better the model is. Now you need to compare AIC of this model with the previous one. So I have to recalculate the previous one. I think that will take some time. So at the interest of time, let's just skip that part. But I think that the idea is that AIC and BCC should be compared, and the smaller, the better it is. But currently, I can predict that the present model is much better in terms of its fit statistics, as we can see by the CFI, TLI, and the norm chi-square value. From the perspective of estimates, the relationship between motivation and language has not changed in any significant way, or has not changed at all, because the p-value is still 0.288. I think the previous one was also around the same number, or was exactly the same. So this probably indicates that, well, motivation doesn't really have any impact on language scores, at least from what we can see in this data set. Okay, so I'd be fine with this model. I think this model can be used as a a kind of generic structural equation model, which shows the relationship of language and other factors like stress, motivation, and positivity, which have to do with the psychology of language learning. One last thing is that we should also make sure that these regression coefficients or beta coefficients are statistically significant. As you see, they are quite fine, with the exception of this one, which is question 3 for stress with a regression coefficient of 0.36. It meets the minimum requirement of 0.3, but it would be better to get something around 0.5, which would indicate that about 50% of the variance in this item is explained by the latent factor or the latent variable. In other cases, you'll see that everything falls well above 0.5, which is good news for our model. As I mentioned before, I suggest that you watch the 2 confirmatory factor analysis videos that I have created and for further explanation of, about how to make sense of these statistics. So that brings me to the end of this video. I hope you found it useful. Thank you very much for your attention, and have a good day.